Okay, thank you everybody for coming to this week's department seminar. So just the usual spiel before we get started. We will, of course, this is being recorded and we have guests who are participating online. At the end of the seminar talk, Dr. Hayes will be moderating the Q&A. If you have questions online, please post them to the chat and we will annotate we'll read out your questions as we go. So with that, our host for this week's seminar is Dr. Hayes, and so I'm going to hand it over to him to let him introduce this week's speaker.
Thank you.
All right, today we get to hear from Dr. Kimberly Ann Webber, who's an engineering executive with 26 years of experience working for the Nuclear Regulatory Commission. She's got over 18 years of safety analysis and licensing experience involving high-level waste disposal, spent fuel storage and transportation, as well as operations and new reactors. She's currently the director of the Division of Systems Analysis in the NRC's Office of Nuclear Regulatory Research. In that position, she's responsible for directing the NRC's research programs associated with fuel performance, source term analysis, reactor systems analysis, accident consequence assessment analysis, and radiation protection and health visiting. Yeah, absolutely. She manages an engineering staff of over 60 employees who develop and maintain broad technical expertise, evaluate experimental data, and develop numerical simulation analysis tools needed to provide the NRC with the ability to make reliable and technically sound regulatory decisions. She's an NC State alum.
So glad to be back.
She got her master's degree through Professor Murdy. And then in 92, got her PhD in material science and engineering. No, in 92, she got her master's, 97, she got her PhD. So, please.
Very nice to be here. I'm so glad to see you all in person. It's a huge crowd. I remember being here years ago and it was a smaller department at that time. And if there's one thing that I can say from today's experience talking with so many of the faculty, you guys are doing such relevant and important research, I have to say. I mean, you know, when I go and talk to the Department of Energy about their programs, whether it's a non-light water reactor, advanced reactor technology, or modeling and simulation, you know, the thing that I tell them is we're all in this together, you know, to make nuclear a reality for tomorrow. And so, you know, every one of us has a responsibility or an opportunity to be an active part of what the future holds for nuclear. So I am so pleased to see such an amazingly large audience. And thanks to those of you who are online for joining us today. So I hope that during my seminar, I would like to engage with questions. We'll hold them to the end, I guess. That's usually the format. My talk is structured, so I'm going to tell you a little bit about what the NRC does. Matter of fact, let me go to the next. There you go. What the NRC does, a little bit about our regulatory research, and some hiring opportunities. But what I want to do for this audience is I have a very few slides that talk about the research that we're doing. And so what I'll do is on each one of those slides, pause and take some questions on it, because I think it's really important as a community that we talk about the important things that are going on. So I want to give you that opportunity. The other thing that I will say is that the nuclear industry business has never been so large, at least in my career of 27 years. And you all probably know that there's really important activities in the Congress to make nuclear happen. They're funding a lot of projects, and they're funding all kinds of reactor technologies, including small modular reactors and advanced reactors. And so it's a really exciting time. And so I'm thrilled to still be in nuclear and see this resurgence of interest happen during my career. And hopefully you all will be a huge part of it going forward. So I'm really, really pleased to be here today. So, you know, I could read the words on this slide, but I'm not gonna. I'm gonna tell you a little about where we came from and where we're headed as a nuclear regulatory agency. So when I started at the NRC in 1996, the focus at that time was large light water reactor technology. And there was all kinds of safety studies going on about large light water reactors. We also are focused on Yucca Mountain. I don't know if any of you know about Yucca Mountain, but Yucca Mountain was a big focus at that time, and has since, gone to the wayside in terms of funding for that. We also focused on the startup. I would call it the startup of spent fuel storage and transportation operations. So taking the spent fuel out of the reactor, storing them on site. And so now we have, instead of one repository at each reactor site, we have spent fuel storage facilities there. So that's the nation's solution for that at this point in time. And then we also had medical devices using radiation sources too. But since then, there have been advancements in technologies where we use sources to cure cancers, for instance. So now the NRC is focused more than ever on protecting public health and safety and the environment, but we want to make it possible to license these different technologies. And so, when I'm fast forwarding now, I think about advancements that are being made by a lot of different companies in the nuclear field, and they're trying to focus on safer reactor technologies or safer medical devices or safer applications of nuclear. And I think that's a really important aspect of why nuclear's got to be a solution for clean energy in the United States. So I'm really proud to be part of the NRC's mission. I personally have always had an interest in being in a service organization. And so with 3 engineering degrees, this was a possibility for me to give service back to the community in the guises of this mission for protecting public health and safety. I never thought I would see the advancements, but I'm really glad I'm part of it towards the end of my career. And so I really like the slogan at the top of this slide. I stole it from one of the licensing organizations, and the NRC's focus now more than ever is to make safe use of nuclear possible. And that's a mantra that we use in the agency to remind ourselves that we need to focus on the most important aspects of anything that comes in for licensing. And I'll talk a little bit about what licensing means momentarily. But as this slide shows, we regulate not only power production, but we regulate the safe use of radioactive materials and industrial and academic uses. We license your reactor that's here. We regulate storage, transportation, disposal, waste disposal, physical security sources, and cybersecurity. And really, again, just going back to the mission, it's to keep all of us safe, including the environment. And the one thing I want to reflect back on again in '96, so the NRC was taking exceedingly long times to review applications for large light water reactors. And the one thing that I personally was involved with was licensing the AP1000 pressurized water reactor. That was a six-year endeavor. And then it was a 10-year construction cycle too. So that's 16 years. And it's billions of dollars to actually make that a reality with the recent startup of Unit 3. We just can't afford that. And because of that experience, the NRC is being pressured to do their licensing reviews more efficiently and to focus more effectively on the safety aspects. Whereas in the past, I know that by personal experience, some focused on nice to have information, but risk is going to be a huge component of what we focus on. So we're trying to make risk-informed decisions. We recently licensed the Hermes construction permit test reactor, and that test reactor was reviewed and evaluated in 24 months, which is an amazingly quick schedule. And a large part of the reason why we were able to do that is what I'm going to talk about momentarily, with my staff getting ready with modeling and simulation and analytical capabilities to actually have the licensing organization understand how those reactors operate. So let me go on to the next slide. So how do we regulate? We license, as I said, licensing, what that means is someone who wants to use nuclear materials, they submit an application, they tell us how it's going to be used, what the consequences of interrupting safety features are, and we give them a license. Much like when you go and go for your driver's license, you have to demonstrate you can drive the car safely. You go and get a permit and you get a license. So we actually give them a license. We also do a lot of oversight. We have inspectors who are at nuclear power plants. Usually 1 to 3 inspectors are at each of the operating plants. That may change in the future because of the smaller footprint of the upcoming plant designs. We also evaluate the security of these facilities from a perspective of security of the facility and security of devices. So well logging devices use sources, cancer treatment devices use sources. So we're looking at those too. During the Fukushima accident, the NRC activated its Emergency Response Center to support Japan and the authorities and to provide technical assistance and advice on how to respond to that accident. So that's a key component of what we do. And then we also write regulations, revise regulations, which is not the most interesting thing to do, and write guidance to support all of this licensing activity. And then the most fun thing to me is we do regulatory research, and that's why I got it colored yellow. Now you see the QR codes on here. I've sprinkled the QR codes throughout the presentation, so if you want more information, you can just click, with your camera and get more information. This QR code at the bottom left here will take you to all the information about what my office does in terms of the research that we do and undertake. So, so hopefully you're getting an understanding that our focus is preparing for tomorrow's electricity production. That's one big focus. I mentioned a couple others, but right now there's a lot of interest in new nuclear technology. I think, Jason, you asked for a QR code for non-light water reactors. So that QR code will take you to a page that has other pages and you can get more information on that. See if there's anything I wanted to say. Okay, so now the fun slides. These are what I call the goodie slides. Most of these pictures that you see come from the research that my staff is involved with and does. And so, I want to talk a little bit about TRACE. Many of you know our TRACE thermal hydraulics code. Many of you know the Parks neutronics analysis code. Those codes were largely light water reactor based codes. And so when we have this interest in the United States to focus on non-light water reactor technologies, we had a gap. And we had a big gap because the vendors out there are talking about building sodium fast reactors, high temperature gas reactors, micro reactors, and molten salt reactors and everything in between. And so we needed to get our tools and our capabilities built up to solve some of the challenges related to that. Additionally, you see on the right a picture of the BWRX 300 small modular reactor design. That's a light water reactor design, but it still has very unique issues in that it largely relies on natural circulation for cooling. So that's one that we're spending a lot of resources and research to try to make sure that we get it right and that we evaluate the design for that GE Hitachi small modular reactor. In the center, does this work? Yeah. Well, let me just talk about this picture over here. So what this picture is basically a power distribution of a cross section of a core that my staff analyzed for what they call maximum extended load limit line analysis. And what that means in large light water reactor space is the owners are actually changing the flow patterns. So the flow, I'm forgetting the actual mechanism, but they're trying to evaluate that if they reduce margin to the safety of the power plant by changing flow conditions, the power starts oscillating. So if I was able to figure out how to link that to a video, what you'd see is the power oscillating across the core. And so it's an instability in the operations of the reactor. So that was an area where we relied on a lot of research to understand what are the causes of those instabilities. Reactor. More recently, I'm curious, how many of you have heard of blue crab? A couple, a blue crab code suite? Couple? Okay, yeah. So blue crab, we're from Maryland, right? We like blue crabs. And we collaborated with the Nuclear Energy Advanced Modeling and Simulation Organization at the Department of Energy. Remember, I talked about the gaps with our codes with TRACE. So NEAMS, in the NEAMS program, they have codes that actually address some of those gaps in terms of neutronics and thermal hydraulics, and some other features. So what this chart shows is we adopted this Moose code, which includes coupling and tensor mechanics with some of the NRC codes, the trace thermal hydraulics code, Parks neutronics, scale provides cross sections to the analysis, and we have the NRC's fast or fuel performance code, and the blue colored boxes are for DOE codes. Bison is their fuel performance code, SAM is the systems and core thermal hydraulics code, Griffin and neutronics code, etc. And so what we're trying to do is link up the capabilities for all of these codes to be able to do the analysis that we need to do, especially when you need coupled thermal hydraulics and neutronics calculations to be done. So this work that we've been doing as represented by blue crab diagram, we've been doing over the last 6 years. The NEAMS program, those codes were a couple $100 million, which they gave to us free of charge. They had developed them over 10 or 15 years. And so that was a benefit to us because we don't have that kind of funding at the NRC to do that kind of code development. And what you can see on the left side, this chart that says coupled code simulations. In this particular simulation, my staff is trying to understand the physics of this prismatic style of reactor. And they create what we call reference plant models. So a reference plant model is based on the design of a publicly available plant design. And the staff working with Idaho National Lab and Argonne National Lab has now created a library of about 10 reference plant models that represent a wide spectrum of non-light water reactor designs. What they do with these reference plant models is they run them through the codes to learn how the plants or the reactors operate. They're essentially learning how to do this kind of work, and they're also making sure that the spaghetti of this blue crab works so that you have all the codes talking to one another. So the reason why we're taking this approach or have taken this approach is to do all of this work in advance of the receipt of applications from these advanced reactor companies. So the idea is if we get a basic model together, run it through the codes work, they get the right outputs that we anticipate, then when we get design specific information from the vendors, it's a lot less time to get up to speed to be able to produce an analysis that we need to support our licensing space. So this is another example of, a Serpent, the neutronics code, and it's basically the flux across the core distributed in 3D in the core. And all of these cool pictures. As a senior manager, I love these cool pictures. And I love it when my staff tell me what this is all about. I don't personally understand all the details of what it's about, but these, today, I just remember, when I was working on my PhD, I had one of the first Mac computers, and I think I used floppy disks, and I think it had 10 megabytes of memory, and I remember my dissertation was picture intensive and it would crash. And here we are today, and we get to do all of this cool stuff with the computing capability, that we have. And that gives us a better understanding of some of the physics that take place in the core, and in the reactor itself. Let me just stop there. Any questions before I move on to the next topical area? Yeah.
So you mentioned that you imported a lot of codes from the DOE, which is an entity whose interest is to promote nuclear
Yes.
energy. So are you verifying those codes yourselves?
Yeah, great question. So yes and no. There's not a lot of data out there, right? So that's a question for anyone who's going to design these type of reactors, is where do we get the data to validate the physics models, to validate, the operations of these power plants. So because we don't have the resources to do actual experiments in, our own facilities or in the facilities of others, we're relying heavily on Department of Energy, on their advanced reactor technology experimental program to obtain data, and on the code developers themselves to validate those codes. So that's a very good question. And, quite frankly, my concern as a regulator is not having a lot of data to validate codes means we're going to have to put large safety margins in important figures of merit, like with large light water reactors, the figure of merit is cladding integrity or cladding, the cladding temperature limits. With these other types of reactors, they're going to be different figures of merit. Well, we're going to have these large uncertainties, which basically means that the plants are going to be over-designed. It's going to be expensive at first. So I think the notion of these small modular reactors is really a way to get investment into these designs and prove, the capability of this technology. So an example is with the Hermes test reactor. We used the methodology that I described earlier, didn't have data, a lot of data. The vendor supplied the data that they had. But we were able to do an analysis to show how that Hermes test reactor would work. And they were able to license it in 18 months, 18 to 24 months, I think it was. So there's gonna be fits and starts, I think, with the non-light water reactor community. But again, as a community, including universities and the research that you all are doing, I think we're going to get there, and I think, in your lifetime, you'll see this be such a prevalent technology for producing clean energy. Any other questions? Yeah.
So follow-up questions. So most framework has the NQ1, the NQA1 certification. So where does the NRC stand in terms of?
Another great question. So we do not NQA1 our own codes, but we do have a quality assurance standard for our codes. And there's a regulatory guide. I think it's 1.203, and it talks about how you ensure the quality of those codes. Now, I think some of the NEAMS codes have that pedigree of quality assurance, but I'm not sure. But that is something that we definitely need to talk about, because the expectation from the vendors is that their codes have a quality assurance pedigree to ensure that what they're predicting is indeed what we hope to see. Very good question. Any other questions? Okay, any questions from the audience? Can anybody see the questions from the audience?
You have to click
I
on it.
can't, oh, okay. Not sure.
Let me try it. No, there's no questions in there yet.
Mhm.
You're good.
All right, thank you. Let's see if I can include that, okay. We're moving right along. So another area that we're doing research on the left-hand side, you see this plot, these plots of data that we're trying to understand with high burnup fuel. This is for light water reactors. The industry wants to get more economy out of their power reactors. So they want to go to higher burnup fuel. If they go to higher burnup fuel, they need higher enrichment of U-235 in the fuel. And so we're trying to investigate, well, what could happen if they go up to these burnups? And you can see, you know, these two pictures with what we would call fish mouth openings in the cladding. And so we're trying to understand that better. It remains to be seen how far we can really go because, you know, what happens? Okay, if you get particulate fuel into the coolant and it floats all, you know, in coolant loop, you get hot spots in the reactor. And, you know, if I was a power plant, I wouldn't want that because it creates a lot of cost associated with cleaning it up. So they're going to have to do some analysis to evaluate in the core, you know, where are the hot spots likely to be? And I know that there's a lot of analysis ongoing in that regard. And I think my staff's also doing some work to evaluate in different fuel loading patterns and cycles, where are the likely places where you might see this happen. But this accident tolerant fuel research has been going on now for over 10 years through the Department of Energy, who sponsored a lot of research on the accident tolerant fuel cladding. It's chrome coated zirc cladding, fecral cladding. I think I talked to you earlier about fecral cladding and silicon carbide clad fuels. So it's a pretty interesting field. And then this is just a representation of a model that shows the heat in being generated in a non-light water reactor. I don't know what reactor type it is. It might be a prismatic type reactor, but I'm not quite sure. And then we're doing a lot of work on triso fuel to understand the behavior of triso fuel. There's not a lot of data on triso fuel failures, and so we're trying to understand that as well. And then you can see a couple of pictures down here where there's, you know, some cladding that's been exposed in air and in steam, and what that looks like in an irradiated experiment, a heat-treated experiment. So all this to say that we're trying to be modern regulators. It's hard to be a modern regulator these days, but we really are trying to be ready to anticipate some of the challenges that we might be faced with the industry progressing. Any questions on this slide before I move on? Okay, and let me see if I can, there's none in the chat, so let me move on. So we're also, I don't know if any of you know about our MACS, our accident consequence code. It's a code that basically takes the source term from a severe accident code like MELCOR, and it evaluates what's the consequence of spreading the dose outside of a reactor. And so what you can see here are different factors that are evaluated in this MACS consequence code. So we look at, you know, atmospheric transportation, we look at evacuation routes, we look at ingestion, and all these other aspects of calculating dose to people. So it's a very important code, and we made modifications to address some of the emergency zones, smaller emergency zones, which are going to be a thing of the future going forward. We're also looking at AI and trying to understand how the light water reactor industry may use AI to make their operations more economical. So the things that we hear about, they have corrective action program where they're looking at maintenance of components. They have a lot of data, they've accumulated a lot of data. They're using some machine language techniques to evaluate it to determine what is the maintenance and the outage maintenance schedule for different components that are in that maintenance program. They're also looking at using machine language to look at non-destructive examination data and using that to more accurately determine whether there's a flaw of interest so that the human can go and look at the flaw of interest. The NASA is really gearing up towards using nuclear sources for heat in those devices. And so we're getting involved with evaluating the consequence of a potential mishap in space and trying to understand, what that could do. And then in the radiation protection and health physics area, and there's a little QR code for you too, and you too, and all the other HP folks. Who's in here is an HP student? Okay, good. Glad to see it. So we at the NRC, we have a suite of, I don't know how many codes there are, but a lot of codes. And those codes do a lot of things. We have codes that evaluate dose to humans, dose to animals. So we have dosimetry models for animals. We have codes that evaluate atmospheric transport. We have codes that are used in our operations center to evaluate what could happen if something bad goes wrong in a power plant. We also are investigating more recently the use of these drones. These drones, in this case, what we're trying to do is see, can drones reproduce a survey of a decommissioning site to figure out what the dose shine is from those decommissioning sites. So I think that's going to be a technology that's used more widely. Let's see what else. We got some phantoms over here. So we use these phantoms to basically model doses to human parts of the body. And then this, can I pet my pets? So it was a really interesting project. So, in today's modern age, these technologies are being used for pets, cancer treatments of pets. And so the question here is, if a pet has a cancer treatment, are they giving a dose to its humans? So this was a research project to evaluate dose to its humans. Any questions on this slide? Yeah.
Can I have my pen?
If you'd like to. Yeah, I mean, just like.
Sorry, it's a leading.
Yeah, no, it's great. I mean, as with any kind of treatment with a radiation source, there's certain restrictions and when you get certain cancer treatments, you stay in a hotel. So we're also evaluating, well, what's the effect of a person with a cancer treatment staying in a hotel room? And what's the dose on the person on the other side of the wall? So these are some really interesting, health effects that we're looking at. Thanks for the question. Any other questions? Okay. All right, so how can you get involved with the NRC? There's a couple ways. So I'm going to talk to you about our grants program, which some of you may know about. And then we, at the NRC and in the nuclear industry at large, are suffering because we don't have enough people to do the good work. So I know that there are shortages in the national laboratories. There are shortages at the NRC. There are shortages in the vendor, in the developers. And so, the pitch here is part of the pitch is we need grad students too. I know this is not an undergrad seminar, but we also hire grad students as well. So with the grant program, the goal really here is to provide funding for folks like you, faculty, students with scholarships and fellowships, to really learn about nuclear technologies or learn about aspects of engineering disciplines that can support nuclear in the future. So that's why Congress established this program. So NRC has a program, Department of Energy has a similar program, and NSA also has funding for these kind of opportunities. And so for the NRC's program, we award 16 million per year to faculty, student scholarships and fellowships, and research and development grants. And you know, I was actually a recipient of a DOE fellowship way back in the 90s, and I'm sure some of you have grants and fellowships from either DOE or the NRC, but the other bucket is NSA. So if you haven't, you know, found that bucket, that's another source of funding. But for the NRC, we've awarded $190 million since 2009, which is pretty good. And you know, while it can seem sometimes frustrating to not understand the selection process, you know, we get all kinds of grant proposals from all kinds of universities, tech schools, trade schools. And so it's a difficult choice to figure out how do we fairly and equitably distribute the funding for this program. One thing that's really exciting, at least from my perspective, so my boss, I don't know if any of you know Ray Firstenow, you know, what he saw is the 16 million was going specifically to faculty and student development. And what he saw was just an opportunity for the universities to do NRC mission critical of interest research. So Ray started the effort in 2020 to set aside about $10 million that go to universities to do that kind of research of interest to the NRC. So on the right-hand side, you can see some of the areas that are listed in the funding opportunity announcement that goes out every year. And safety analysis for reactors designs and fuel cycle technologies covers everything that we've talked about so far. You know, fuel performance, systems analysis, severe accidents. So, and even, I know that some folks have commented, well, do I have to have, you know, a proposal that lines up with one of those bullets? And the answer is no. These are suggested areas. But if you have some novel research that you think, you know, could benefit the community, I would encourage you to put in a proposal for that. Let's see. Okay, it's interesting. So for the cycle of grant selections is a little funky. So you can see where it says fiscal year 2023. The funding for that program was in 2023. Our fiscal year starts on October 1st and ends September 30th. The funding came in 23, but the whole process for selection, you know, takes more than you know 12. Well, it takes 12 months, but it occurs into 2024. So what you can see here is that we're just going to start for the 2023 notice of funding opportunity for educational grants. We're just starting the evaluations, and then we will make awards in April 2024 with the next round notice funding opportunity in July 2024. For the research grants, the R&D grants, we expect to, well, I think we already made announcements about the selections, and I think NC State received some awards from that. And actually, you know, congratulations to all of you. Since 2009, NC State has been awarded $5.8 million. So congratulations. Yeah. That, you know, to me, that says you have quality proposals that are of high interest to the NRC. You have quality nuclear engineering department programs. And these awards aren't only for nuclear engineering department, they're for other engineering departments across the university. But congratulations to the university as a whole, because I think that's a really good track record. All right, so now I'm going to talk quickly about employment opportunities. Yeah, I have to say, so I met Sam. Sam came into my office, we scheduled a meeting, I talked to Sam, great student. Oh my God. he came with a whole list of questions about careers, you know, NRC and what we do, and he showed initiative, which I don't always see in students, you know, so if there's one piece of advice when you get to look for a job, show initiative, because that says a lot about you on the first impression with a potential employer. And, you know, when Sam came, I'm like, damn, he's good. You know, so anyway, he came in through the summer intern program. And, you know, I thank you for reaching out to schedule this. You and Rob have really, I really appreciate the opportunity to come and talk to you. So thank you. All right, so summer interns and the co-op program. So for the summer intern program, it's essentially a 2.5 month summer intern where you apply online, and I've included the QR code right here on the right for the application process. The posting closes on the 30th of this month for next year's summer intern program. And the agency, this is probably one of the most successful hiring programs that we have at the NRC. You know, in my organization of 64 people, over the last 4 years, I've hired 6 from this program. Because what we can do is good folks who come out of the student intern program, we can convert them into co-ops and then directly hire them. They don't have to go through another hiring process. So that's why we really like the summer intern program. And you know, the thing that I ask my first line supervisors to do is give students important, I'll say the word, sexy projects, you know, so that you can put on your resumes. You know, you're the next generation of nuclear experts. So we really focus on giving our summer interns really interesting projects so that they want to come back and they want to be a part of something that's exciting. So there's information on the summer intern and co-op program. The co-op program, there's a FAQ at this QR code here. There's no vacancy announcement for that. It's usually through the summer intern program that we convert students to the co-op program. And that co-op program, some students come back two times, 3 times, depending upon where they're at in their educational process. But we look for folks with bachelor's, master's, and PhDs, all engineering and science disciplines.
You do have a question on the chat.
Okay, all right. Is the person chatting with me in the room? All right. In your requirement, US citizen was mentioned. Is that work? No, I'm sorry. So this means that you have full US citizenship. It's a federal government, and in this case, because we're dealing with nuclear, it's a requirement, it's a condition of employment to have a citizenship. So I know that excludes some folks who may be interested, but I can't do anything about that one. So thanks for the question. Hopefully I answered it sufficiently. Okay, and thanks for telling me that there was, oh, yeah.
Follow up on that question.
Yes,
What if you're a dual citizen that has American and another country's
I
citizenship?
think that would work. Yeah, I think that would work.
Some places it depends on the other country.
Yeah, and it might be that here too. So thanks for mentioning that. But I think I'm trying to recollect. Do I remember employee? I think we might have some, but yeah, thanks for the question. I'm not an HR specialist, unfortunately. I know a lot about a lot, you know, at this level, but I'm not deep in the HR area. Let's see, is there another chat? Oh, yeah. Okay, you're welcome. Glad I could answer that question. All right. All right, so this is an exciting program. We call it the Nuclear Regulatory Apprentice Network. And if you're in the program, we call you an NRANer. An NRANer, because they do amazing work. So it's a very competitive program. And the reason it's so competitive is because we offer not only training, training on the NRC, what it does, but you get 3 internships, or what we call apprentices, in 3 different parts of the agency. So what has been happening in the last 2 years is you might do an apprenticeship with an inspection organization, or a licensing organization, or a research organization. And what's really cool about this that I really like is at the end, you get to have a say somewhat in where you want to work. So, there's 25 students who are usually admitted to this program, and there are 40 slots that are available at the end of the program. And if everybody wants to work for Kim because they like her research, we can't take everybody. And so, the agency has to figure out best fit. But that doesn't mean that later on you might not come back to the organization that you're really interested in. So this program is for health physics, earth sciences, engineering, and a couple other disciplines. I've been a mentor myself of someone, an NRANer, gone through the program, and the caliber of folks is just amazing. I mean, again, when I think about, where I've come through the nuclear industry in my career, these folks are our future when it comes to being the regulators of tomorrow. And if you want to apply, here's the QR code, and the vacancy announcement closes at the end of the month. And citizenship is required for this too. One last thing, so we do have entry-level hiring. What that means is you don't have to go through a summer intern program, you don't have to go through the NRAN program. And we're looking for folks in our licensing organizations, in our inspection organizations, and in the research organization. And I threw on the slide here on the right is some of the technical disciplines that we're looking for. Over the last few years, the agency has been focused on hiring health physics folks. And starting 2-3 years ago, we actively recruited in that area. And due to the active recruitment in that area for us has come up quite a bit in terms of filling those slots. But the agency is really struggling to get expertise in some of these other areas. And what I did was I put the QR codes to the postings for each one of these opportunities for any bachelor, master's, or PhD student. We'll take everybody, everybody who's interested. Where are we located? Just as an FYI, because some of those postings are location specific. So the headquarters is in Maryland, right here. And then we have 4 regional offices. One's in Pennsylvania, another's in Chicago, the other one's in Atlanta, and one is in, I can't remember if it's Arlington, Texas, which is near Dallas. If you want more information, you can click on this QR code, and then the benefits. So I'll be the first one to say that if I wasn't working where I am now, working outside, I'd be making a lot more money. But to me, work-life balance is so important. So we do offer competitive salaries, but you can get higher salaries elsewhere. We offer flexible work hours and flexible schedules. Even as an executive, on average, I work 40 hours per week, which is pretty good. Yeah, it's pretty rare. They give you amazing health benefits, and the retirement system is amazing. We give a pension for a number of years worked. So when I'm done with my 30 years, I'll have a pretty significant pension, in addition to a 401k, which is another retirement benefit. So that's one thing that many companies don't offer anymore. And then we have a couple other benefits. I heard a story about one company was sending a young person to a conference, and they had to use their own personal leave to go to the conference. And that's not something that we do. We treat our employees with respect and honor their own times outside of the NRC environment. And I think that's it. Any Any questions?
All right, well, let's thank our speaker.
Thank you all. I mean, it's such a pleasure to be here and see your faces and smiling. I see lots of great smiles, so thank you for coming. Any questions? Yeah.
You mentioned a couple of times the Hermes CPA that took 24 hours and
24 months? Yeah.
And that's
Per-
CPA for testing
Oh.
facilities, so it's a different pipeline than
Yeah.
full licensing.
So you're correct. Man, you are good. Are you looking for a job? So the Hermes construction permit was for a test reactor. That's an amazing first step for an actual reactor that puts power on the grid. So Hermes too, Kairos has just submitted their application, or they're going to submit an application for Hermes too. And they're gonna put a 2-pack, I think the plan is to put a 2-pack at TVA, at Tennessee Valley Authority. But that's, from the NRC perspective, with such a novel advanced reactor design, that's the best approach that these vendors can do.
Can I have a follow-up?
Yeah,
So Kairos' approach, especially to reliability, is the experimental side, that's why they have a lot of data.
exactly.
Are you prepared to a vendor who comes with a more theoretical approach?
I was talking with somebody earlier, so when it comes to theoretical is what, paper napkin? Yeah, no. No, I mean, so one of the key aspects of ensuring public health and safety is they gotta meet our regulations. They've gotta demonstrate that they meet the regulations. If they can't demonstrate they meet the regulations, they won't get a license. So they have to have something more than theory behind their reactor technology. That's a great question. Did I see?
You said that in order to reduce the timeline for licensing, you had to kind of focus more on the safety rather than just safety and nice to know.
Yeah.
So what are those things that requirements that you perhaps gotten rid of, or what are the nice to know things that you're not as keen to know?
So that's a great question. So there's been a debate within the agency. Quite honestly, there's been a debate about nice to know question versus have to have questions. And depending upon what aspect of the safety analysis you're looking at, it's going to be a different answer. So, like light water reactor fuel, we have to understand what's the maximum temperature that the reactor is going to produce in that cladding to make sure it's intact. That's have to have, but, how they want to operate the reactor, what are the cycles of, how they shift fuel in the core? Like, we don't need to know that, so we're focused more on the safety versus the operational aspects. That's one example. But in every aspect of safety, there are different factors. Yeah.
Kind of like my
Yeah.
colleagues here question, when you said that they need to meet the regulatory. So my question about the microreactor, what is the NRC standpoint licensing transport microreactor, especially we see.
Oh, transportable microreactors.
Especially we see the interest from you.
Yes. So we have what we call a memorandum of understanding with Department of Energy and with the Strategic Capabilities Office to understand what they're doing with that transportable microreactor. And that concept brings in a lot of policy issues related to safety. And so we have to engage our commission. Our commission has 5 political appointees. And so there are various safety attributes of that configuration that we need to understand. And one thing that I think about is, okay, you got this reactor, it's on a truck bed, it's got fuel in it. Well, if it's shaking around, like what happens? Is that okay for the fuel? Maybe for some forms of fuel, it's not a big deal, but I'm not doing a really good job to describe the policy issues. But if you wanted to know the details, we just are sending a white paper out that talks about policy issues.
And in terms of scientific, what kind of food development in NRC?
What did you say?
I'm saying in terms of food and scientific technique, what we can see from NRC, because most of the food is
developed in 1995.
Yeah,
Even all the including for reactors that has a specific location or
Yeah.
selected area.
yeah. Yes, so we're going with this. This is what we're gonna use for all the non-light water reactors. And the notion is that having that infrastructure, I'll say, having that infrastructure will give us the flexibility to look at each one of these designs individually. I don't know if that's the
But
answer you're looking
this
for.
kind will be just only in terms of technical, so how about assessment?
Oh, yeah. Oh, so seismic, external events, seismic, winds, tsunamis, all of that has to be evaluated.
And
Even if it's for transportation, they have to evaluate, well, like what happens when you're transporting and an earthquake, happens? They have to come in and show why that reactor is still in a safe configuration. Is that what you're, okay, thanks for your question.
So I saw that you had a slide about AI.
Yeah,
So I was curious to ask, how does AI in its current state play a role in the design validation and licensing process, if at all?
zero.
Zero.
It's all human based. However, I don't know if any of you have tried to find documents in the NRC's Adams library. It's a disaster. It's been a disaster. And they, so 4 years ago, I complained to our chief technology officer, we need a Google-like search. We need a Google-like search to get the data out of there. So they're making small advancements to try to use natural language processing and other capabilities. And with that, so now we have a Google-like search for atoms. It's okay. Maybe not quite like Google. It's definitely not a chat GPT of any stretch of the means. But we have thought about the ability of AI NLP to dig through all those records and find trends in decision. So that is something that, we're thinking about that could save time. In the end, the human would still have to make a determination, but it aids the human in trying to pull the relevant information together. But any other questions? Let's see if there's any online. How would I know if it's online? Okay. Chat, we'll chat.
I have one.
Yeah,
In terms of NRC independence for analysis, you're adopting the
Yep.
DOE speed code.
Yep.
Have you looked into what are the pitfalls and the limitations of using that?
yep.
Somebody's gonna develop an analysis. You're gonna use the same approach.
Yep, so our philosophy, great question, number one, regulatory independence is absolutely critical. And so before we embarked on this, we actually talked about, what if Kairos uses our same suite of codes? How can you guarantee regulatory independence? Well, Kairos is gonna use their codes for design purposes. They're gonna have different models. They're gonna have different information than we use in our own input decks. Largely our input decks will be similar to theirs, but they're gonna have a lot more details to design that reactor than we need to make a safety finding. So we've convinced ourselves that if a developer uses the same suite of codes, we still feel that we can do an independent safety assessment with the same codes.
I'm asking more, I understand now, we need this.
Yeah.
There's no question.
Yeah.
About why we need them now.
Yep.
But for the medium term and long term strategy of NRC, you yourselves developing these capabilities in-house.
It's a great question, and we've gotten that question from our advanced ACRS, I forget what the acronym is, I'm so tired. Yes, Advisory Committee on Reactor Safety, they've asked us the same question. So our trace code and some of our other codes do have non-light water reactor capability. For instance, our trace code has sodium fast reactor capability. It's not to the same degree that some of these other codes have, but we do have some capability. Are we going to develop them? No. The notion is, the notion is that we feel confident enough in Department of Energy's funding of this program, especially when Congress tells the NRC to work with DOE You know, in the modeling and simulation area, we have confidence that it'll get funded. You know, could it change? Yes, it could change, but currently that's our approach. Yeah. Anyone else? Oh, yeah.
So I see that, Kairos is building an Oak Ridge. Agree, which is terrifying to be built that way. Is this just a natural fit that these test reactors are being built at DOE labs, or is this
Yeah.
just make a really
Yeah.
strong case for the NRC to license or these testers?
So that's a great question, and there are also test reactors being licensed, cited on Idaho National Lab as well. And the rigor of the DOE safety evaluation relies heavily on the NRC evaluations. But because they're including other aspects of the testing that are safe, like they're putting some of these small microreactors in the EBR dome that provides a containment, then their safety pedigree relies on not only the inherent nature of the safety systems and features, but that dome. And, you know, once we get data from that, you know, they should be able to use, that vendor should be able to use it for license. So that's why we see a lot of interest at citing these things at the national laboratories, because they have other aspects and features where they can make sure that there's additional safety measures. Good question. Any other questions? You've been an amazing audience. Thank you so much. I really appreciate your attention and questions. And again, we need folks, masters, bachelors, PhDs, you know, please reach out. I think my contact information is there. I'm kind of, you know, old person with, you know, the little Kimberly.Webber at NRC.gov. I think you could probably do a QR code on that or something. I don't even know. But anyway, you know, best of luck to you in your careers and congratulations on working for such an esteemed department, the NC State Nuclear Engineering Department. Thank you.